Addendum to video 4. The pins on the ECU connector are not connected to the circuit until you add these jumpers. So if you're running an MX5 or variant, or you're going to rewire the pigtails coming out of this connector to your loom, it might be an idea to add all these 0 ohm resistors before it goes in the solder oven. There's only 30 in the kit, so you either have to buy more or add wire jumpers. I'll cover it in a bit more detail further in the video. The repairs were removing bridges across the STM32 footprint. You don't know what they're bridging. It could be power straight to ground, so you have to get rid of them. And the program USB. Also the bridges on the Max 9926 VR conditioner. Some flux. I added solder, but it probably didn't need it. Then just wicked off. Some draw soldering across the pins. A quick spin around to do the other side, and just a straight wick. I'm not going to worry about the misalignment. Another mistake is the joystick is directional. If you go to the data sheet and down here, you'll see the push button uses pin 1 and 2. So this thing is not symmetrical and can only go in one way. Pin 1 is here, but if you look at the KiCad, pin 1 is down here. The silkscreen has a large mark here, and if you look at the joystick, the V is here, which is what it has to line up to. This notch lines up with this mark. I was able to get the joystick off without hot air just by double wicking both sides with fresh wick. One side just popped off, but the other side lifted half a pad because it was still attached. The first through-hole part of these 3 inductors. These are just coils of wire on a ferrite core, so they don't have a polarity, so can go in anyway. As a word of warning, these inductors are very fragile. The legs are glued into the holes in the ferrite core, and if they're spread too far in fitment, they can crack the ferrite. I had to glue this one down after one cracked on me. We tick that off. Next is D1002, which is a vertical anode up diode. The line marking goes on this side. We tick that off. Next is D1003, also vertical anode up. Part line on the same side as the silkscreen line. The ground plane side of the diodes had a lot of thermal mass, so I had to switch to a bigger wedge type tip to get enough heat into the joint. And we tick that off. Next is an 8 MHz crystal. I assume we're not using the STM32 one, so it must be this one, the X161. 4 MHz on the packet must be a typo, because it's 8 MHz on the crystal. There's no polarity on 2-pin crystals or resonators, so you can put it in either way. And we tick that off. The next part says it's keystone, and they are the 2 pins that hold the fuse. That's this thing up here. You can bend the pins over for more mechanical strength in case you ever have to remove the fuse. We can tick that off. Next is the headers. The double rows are easy enough because they're for the STM32. Just press the headers onto your STM32 board. Put it on your Frankenso. If you have spare female header, just put the headers in the corner to improve the strength of everything. Then solder the pins. The proper technique is heat one side of the pin and feed solder into the other side. This releases the flux in the solder right onto the joint. I usually dip my solder into flux and add even more. I found soldering from one end to the other better than random because it preheats the next joint. Next is the 2 6-pin male and female headers, and they're not specified. If we look at this picture of the Frankenso board on the forum, there's a row of headers here, and they are for the display. And I eventually found a link in the wiki to this hidden picture. But if you look at the display, it's got 6 pins on this side and 6 pins on this side. So that's where those 2 6-pin headers must go. I had spare headers, so I put a full-length one in. Get the brass standoffs. Just put the display on with all its standoffs and tighten the nuts. The standoffs are too tall for the header, so you can either file them down or leave a gap between the headers before you bolt it down. Then just solder the top and the underside. It's best to have the male header on the display side, so it's breadboard friendly, and the female on the PCB side. Also, a forum pic shows some brass screws on top, so the nuts must be underneath. Fit the connector. Make sure you clean under it because you won't be able to get to it later. Screw it down. The outer screws can be bigger, but the inner have to be small head 3x5, maybe 6mm long self-tappers. You might even need insulating washers to stop the heads shorting across pads. Then just solder the pins. Lastly, we come to these flyback diodes. If we go back to the bottom side, you come to this D12 to D23, and it's a bunch of diodes over here. Now going to the schematic, it says optional D12 to D23 for solenoids. Only used in rare cases where the topology requires this flyback diode. Flyback is when you energize a coil, it creates a magnetic field, and when you disconnect the power, The collapsing magnetic field sends a flyback pulse back down the wire. This can be solenoids, relays, VVT, inlet air control, anywhere where there's a coil of wire, and it's this diode that stops that. There is one on page 8 of the forum, but I don't know what it's protecting. It says rare cases, so I assume you can leave it off unless you have a problem. The pins on the ECU connector are not connected to the circuit until you add these jumpers. If you come to the manual hardware Mazda plug and play and come down here, it says the Frankenso board was designed as a plug and play for the early MX5 Miatas and derivatives. So if you have one of those, you just put straight jumpers in all of these. If you're using the Frankenso on a car with a different loom that doesn't plug in but have the pigtails, you would also use straight jumpers and just rewire the pigtails to your loom. Using your pigtails and buying another connector like on your standard ECU, you could make a patch adapter cable. If your loom has plugs that plug into a Frankenso, but the loom pinout is different, you can manually hardwire around the jumpers to connect it to the correct circuits. There's also a direct connection to the circuit side of the jumpers that doesn't need the ECU connector nor the jumpers. This is if you want to directly connect to an adapter board, or use a totally different type of connector. If you need this 3D printed strain relief and have a 3D printer, there's a file on the rusEFI Tinkercad. When it comes down to wiring, it's a matter of getting the workshop manual and finding out what each pin does, laying it out in a table, and comparing your table to the Frankenso table. There's vehicle specific pages, and if you have one of these you can go to its page, and there's pinouts and a wiring diagram. The kit comes with 30 0-ohm resistors, which should be enough for old cars if you selectively fit them. I think my 91 Mazda uses about 20. But if you want to fit all 58, which is easy enough to do before it goes in the soldering oven, you'll have to supply another 28. Just on a side note, there's larger high current pins on the connector, and 0805 jumpers seems to work fine even with two high Z injectors on one pin, but there is the option of putting a higher current link across those. I might run 1206s with those pins. If you are doing straight links, this should all be done in the stencil and oven stage, but I had used my standard technique of hold the part down, apply flux from the tip of some solder, preload a blob of solder on the tip of the soldering iron and just solder the joint. Then just solder the far side in the usual way. All the 0-ohm resistors, i.e. jumpers, fitted. All the Frankensos are running fine with a full set of 0805 jumpers, but I went with the over-the-top 1206s on the high current pins. We can tick off our jumpers properly this time. My Frankenso is probably only ever going to be run on the bench, and since I have the pigtails, I made a screw terminal adapter. The pigtails will go in the back in any order I like, and I'll just connect to the front. There are more through-hole parts and links further down, but I'm going to trust this photo. This is an older version of Frankenso, and this one, and not worry about those parts because they're not in these pictures. Also, there's no parts left in the kit. The soldering is finished on our Frankenso board, or at least finished for the time being.